So in this exercise, we need to check if a map L is a linear transformation. So L is given to us as a map from R2 to R3. Map X vector x1, x2 to the column vector x1, x2, x1 plus 2 times x2. They can also give us L of the form x. So x is a vector in R2, x1, x2, and they can give it in the following form: x equal to x1, x2, x1 plus x2 transpose. And yes, and if the statement is like this, we know that it sends R2, the element in R2 to element in R3. Okay, then now we check whether this map is linear. In the L of alpha, say x, plus beta times vector y equal alpha times L sub x plus beta times L of y. So this is a linear condition for saying alpha and beta are scalar. So let's think they are real number in this case. And x, y are just vectors in R2, right? So says x equal to x1, x2, and y equal to y1, y2. Okay, let me call this condition star. The left hand side of the condition star is L of alpha times x1, x2 plus beta times y1, y2. So this is a scalar times a vector, right? Scalar multiplication, and this is addition. We compute this L of inside the brackets first, alpha x1 plus beta y1, alpha x2 plus beta y2, and this is by definition this is this vector in R3, right? x1, x2, x1 plus 2 times x2. So x1 is this, x2 is this, x1, x2, x1 plus 2 times x2, alpha x1, beta y1, 2 times alpha x2, beta y2. So this is this one, which is, we can even stop here and compute the right hand side, and which will check whether they are the same or not. Let me do it one more step. Let's do it one more step by this. So we get this alpha x1 plus 2 times, actually not even necessary, but alpha x1 2 times alpha x2, beta y1 plus 2 times beta y2. Okay, let's stop here for the left hand side. Right hand side is this, and we have alpha times L of x1, x2, beta times L of y1, y2. This gives us alpha x1, x2, x1 plus 2 times x2, right? Beta y1, y2, y1 plus 2 times y2. This is by definition of the linear, the map L. We are proving it's linear, so this equality is because of the definition of L. Now we have two vector. Okay, scalar multiply a vector, scalar multiplies a vector, and then we do the sum. Alpha x1, beta y1, alpha x2, beta y2, alpha times x1, 2 times x2, beta y1 plus 2 times y2. You can do one more step. Which is, the last one is alpha. We can put alpha here, beta here. Alpha x1 plus alpha 2 times x2, so alpha here too. So this is left hand side equal to this one, right hand side equal to this one, and they are exactly the same. Beta y1, alpha, oh I'm sorry, this should be beta. Beta 2 times y2, yep. And hence else is a linear map. We only need to check this condition, and if this is true for any scalar alpha, beta, and for any vector x and y in the domain, then we have the linear map.